Great. So hello, everyone, and welcome to Passion and Science number 3. My name is Jaroslav Merc. I am from IAC, Instituto de Astrofísica de Canarias, and Charles University in Prague. And I'm glad to be the host of this today. I am a member of the organizing committee of the IAU Junior Members Working Group, and this is one of the events that we organized. And it's a real pleasure that within this format, we bring the conversation that we explore, not just the great science, but also the passion of astronomers that is behind the great science. And today's guest is someone that I am very proud to call not only a scientific colleague, but also a friend, Professor Łukasz Wyrzykowski from the Astronomical Observatory of the University of Warsaw in Poland. And hello, Łukasz. So just to shortly introduce you before we start. So Łukasz is one of the leading figures in the time domain astronomy and gravitational microlensing. And he has built a career connecting large surveys, compact objects, and global observational networks. And we will a little bit talk about this in a minute. So he studied astronomy at the University of Warsaw, where he also did his PhD in astrophysics in 2005. And after that, he spent several years at the Institute of Astronomy of the University of Cambridge in UK, where he was a postdoctoral researcher. And during his time in Cambridge, he became very deeply involved in ESA Gaia mission. And I now see that you changed the background to one of the outcomes of this mission. And during his stay, he helped to design and implement the Gaia photometric science alert system, which is also something that I was using a lot, which is a tool that is detecting transient events in almost real time. So then Łukasz returned to Poland and continued his work at the Astronomical Observatory in Warsaw. And in 2021, he was appointed a full professor. So it's my pleasure to have you here, and thank you for accepting the invitation to join us today.
Thank you, Yaro. I'm happy to be here.
So as we plan this, we will start with the science part of Passion and Science, because that is giving us a bit of motivation for then your passion that we will speak about. So I will go through a few questions that I would like to ask you to introduce you as an astronomer. So what is your main research interest and the big questions that you are currently most interested in?
Yes, well, that's a question everyone should be asking themselves. So thanks for asking this. I think I was looking for my science question for quite a long time, wondering, through different fields of, generally speaking, time domain astronomy. I started with variable stars. This is something what we've been doing here in Warsaw for hundreds of years now. So this was my kind of natural upbringing. And then I started doing microlensing, which is again something ogle connected with the telescope we have in Chile. So I was heading towards this direction. But also what I liked in astronomy, actually, that's what actually brought me to astronomy, is the computational engineering side of it. So exploring databases, large databases, and looking for these very rare things among huge data sets, or very rapid things or unexpected things. You don't know when and where something is going to happen. So I was at some point involved in transients for quite a long time, looking for transients in Gaia, in Ogle, and other surveys, gravitational waves as well, this kind of science. But eventually, I think what I found most exciting and most interesting are black holes. And maybe I'm not very original here, because I know this is a topic, almost everyone is interested. At least everyone on the street you ask, someone is interested in black holes or dinosaurs. So especially among the kids. No, but actually it came from my interest and my scientific path. I was involved in looking for dark matter in form of black holes. That was a theory back in 1980s, where people were hoping to explain dark matter as potential, compact objects, right? They used to be called massive astrophysical compact halo objects, like MACHOS. Some people in my generation or older can still remember that name. So we were looking for these using microlensing. So actually, if you see behind me, there is the Large Magellanic Cloud there. And we've been observing Large Magellanic Cloud for many decades to see the short blips due to microlensing if the halo between us and the Magellan Cloud is filled with these small, compact black holes, primordial black holes now people call them. It's essentially the same idea. So after many, many decades of observations, actually, we said, no, that's not the answer. So even though it was an unsuccessful result, a negative result, essentially, but we made science out of it, right? A very important science, because we actually ruled out black hole as potential contributors, significant at least, contributors to dark matter halos. So we didn't answer the question of the dark matter, but we answered, at least we ruled out some part of this question. So that's how I got into black holes. Now I'm involved in looking for black holes within Gaia space mission, and again using microlensing. And the Gaia in particular is a perfect tool for that, because Gaia has been scanning the whole sky looking for photometric and astrometric changes, which is a unique laboratory, and it's kind of Gaia personalizes everything what I was always interested in. So it is a vast database, huge data, and you don't know where the things are, and you need to design very neat algorithms to go through these vast data sets to find these very rare things like lensing by black holes. So this is what I'm after, doing this for like now something like 15 years. But now this is the time, this is the year of the yield. I'm going to have some things in forthcoming Gaia DR4. I'm not going to say too much. Next year we meet, I will show you some real results. Now I can only give you a hint that there is something coming.
So that's exciting. So can you just very quickly explain what microlensing is for people who are not in the same field? Because from what you said, it's still, even with the negative results on black holes being the dark matter thingy, then it's still something that you work a lot on. So can you just quickly?
Yes. So microlensing, it's gravitational microlensing, right? It's a flavor of essentially a strong lensing we see in between galaxies. If you have a background source galaxy and then a foreground galaxy, then if the alignment is right with the observer, then you see the background galaxy being lensed. However, in terms of the regular cosmological strong lensing, this configuration changes so slowly that we actually can ignore the change of the configuration. The difference with microlensing is that you cannot ignore the motion anymore, because then there is this temporal component added to it. We mostly talk about microlensing in framework of our own galaxy. However, there's also the microlensing component when you have the stars of the lensing galaxy in strong lenses, then it's also microlensing. Where you have stars as lenses or star-like objects, and in terms of our galaxy, you have stars also as sources. So you have a background source somewhere there, probably somewhere close to the center where there's most of the stars are there. And if you have a foreground object, which is compact enough, like white dwarf, neutron star, black hole, or just a star, or just a free-floating planet, as we discovered last month, they cause the space-time curvature so that the background light is passing through that space-time curvature, and for a short period of time, the background star gets brighter, but it also shifts its position a little bit. So the changes in brightness can be pronounced, can be 2 magnitudes, 5 magnitudes, actually, whatever. It's just a question of geometry. However, the changes in position are really minuscule. We're talking about milli-arc seconds or sub-milli-arc seconds displacements due to lensing. So this is where Gaia can definitely tell a lot, because Gaia is capable of measuring positions down to milli-arc seconds for all 2 billion sources. So suddenly you have measurements of this perfect accuracy for the whole sky, right? So only with Gaia we can actually look for black holes.
Yep. So that's one of the reasons why you use microlensing to search for things that we otherwise cannot see, right?
Exactly,
that's true. So you mentioned Gaia as one of the surveys that is ideal for this, but are there other surveys that can be used in a similar way?
Well, Gaia is the best, right? And by far. And I'm biased, of course. But of course, there are other surveys, but nothing similar to Gaia. Let me just recap this. So well, apart from the whole sky, photometry for the whole sky, you also have astrometry for the whole sky. You have spectroscopy for the whole sky. So there's no such other survey. There are other surveys which are doing bits of it, right? So we mentioned the Ogle survey. There's the Polish survey, which is still monitoring this part of the sky behind me here. So the galactic center, where there is most stars. Essentially, there is also like another 2 billion stars, which we monitor there for last 30 years. This is the longest running survey, I guess, ever in astronomy. It's a small telescope in Chile, 1.3 meter telescope, but it's dedicated to that problem. And it's been monitoring this part of the sky constantly. So the long time series, there is thousands of microlensing events being found by Ogle. Among them are planets, are black holes, and lensing by stars, just like that. But this is only the photometric component, right? There are other surveys which are observing, photometric surveys. Of course, I'm coming from optical photometry, right? So I'm biased. I only think of these. So in terms of photometric surveys, there is also ZTF in the north. So essentially, the whole northern hemisphere is monitored almost on daily basis, and ZTF is finding, supernovae, tidal disruption events, cataclysmic variables. It's also finding some microlensing events because it goes down to the galactic plane. Many surveys, they are afraid of galactic plane. I will emphasize this. So Gaia is not afraid of that. Ogle is not afraid. Ogle is designed to observe the galactic plane. However, other surveys, they tend to go away from the galactic plane where there is less stars. So the photometry is easier to do. The same with LSST, Vera Rubin Observatory, and then LSST survey, which is coming online now as we speak. Essentially, it's observing the whole southern hemisphere. It's going to, with 8-meter diameter, is going to observe quite deeply. And again, they are afraid of the galactic plane because there is going to be so many stars. Essentially, you will not be able to disentangle stars from one another. So surveys come with different flavors. But these are mostly photometric surveys. There are spectroscopic surveys as well, monitoring selected targets. There are ideas for large-scale spectroscopic surveys. Well, SDSS, for example, old one, it used to have the spectroscopic component, very beautiful data sets, spectra of millions of objects. There's DESI, right, also doing spectroscopy. There is not many astrometric surveys. Essentially, that's what makes Gaia, again, unique, because Gaia provides astrometry for so many sources at once. LSST is going to deliver some decent astrometry, I must say, because it's a big telescope, right? 8-meter, you can do quite a lot. But still, it's nothing compared to Gaia if you are in space. In terms of space missions, if we talk about it, there was, for example, GALEX, right? GALEX was observing large portions of the sky in ultraviolet, which is also very useful. And there are time series of this. There were detections of sources, transient sources. There is Ultrasat coming in ultraviolet, which is going to observe some parts of the sky very deeply, looking for ultraviolet flares. So there is a lot of things going on. There is so much we still expect to discover. These are really fun times we live in.
And that leads me to the next question, because it seems that there is a lot of data already available, and basically Gaia delivering all these products that is needed for your work. But anyway, you are still leading a follow-up network, black hole Tom follow-up network. So why that is needed in this avalanche of data?
Yeah, exactly. So this is something what we realized early on when we were designing the Gaia Science Alert system back in Cambridge. So what's the point of alerting of things, changing things on the sky when Gaia is not going to stop if there is a supernova somewhere here, right? Gaia is going to continue scanning the whole sky because it's on a mission. The same applies to ZTF and other similar surveys. That's the difference between survey and a telescope, dedicated telescope. It essentially has its schedule. It observes the whole part of the sky. So, especially for Gaia alerts, we designed this. We started collecting telescopes around the globe, which are ready to respond to the alerts coming from Gaia, and especially as you see this whole sky. So we are dealing with both hemispheres, north and south. You don't know when and where something is going to appear or disappear. Gaia Science alerts were sensitive to supernovae, cataclysmic variable, young stellar objects, symbiotic variables, then our Corona Borealis type stars, right? Disappearing stars. And then, of course, microlensing as well. So everything what was changing on the sky, Gaia alerts were detecting. However, we had this very short window of time when these events were ongoing. A supernova typically lasts for a month. When Gaia detects it, next time Gaia goes there, the supernova is gone, right? So we lost this chance to study the supernova, to, first of all, to measure its redshift. Well, okay, you need one spectroscopic observation, but then you need the light curve, right? To disentangle the types or measure the expansion of the universe, essentially. You need the shape of the light curve. So therefore, this telescope network was created to respond to these alerts and then collect photometric measurements. And early on, I realized that there's so many telescopes around there that are of, let's say, depends who you ask, but then medium or small size, let's say from 0.5 meter to 2 meter. There is so many of these telescopes. They used to be the leaders in astronomy, but now we're dealing with 8 meters, 10 meters, 30 meters, and so on. So they are kind of left behind, but there's many of them, and they tend to be located in places where astronomy used to be done, but not the best places in the world. But that's actually the benefit here, because we need telescopes dispersed globally on the whole, every hemisphere. Also, they tend to be used for training these days. Also, the weather there is not that perfect. So instead of one telescope, we need like 10 telescopes to be sure that there is at least one of them is going to be available at that moment of time when something explodes. You don't know when and where. I repeat that again. So hence we created this network, and there were many people who were willing to contribute, essentially with their observing time, free of charge. No proposals. These people were essentially donating their observing time. Observatories from Finland, Lithuania, Poland, Czechia, Belgium, Italy, Spain, Israel, South Africa, Chile, Brazil, Argentina, US, Australia, Thailand, Japan. I just browsed you from through the whole earth. There were people who were interested in joining this. So we built this network we now call BHTOM, which stands for Black Hole Target Observation Manager. Black hole because I like black holes, and it's we could either call it black hole or dinosaur, but I think black hole is more suited here. Target Observation Manager is a TOM toolkit, which is a beautiful software suite designed by Las Cumbres Observatory. People who were doing this for like 20 years now. They've designed the telescope network, but the difference was that they had unique telescopes in most places in the world, and they acted as one observatory. So we wanted to use their expertise, but expand it to a very heterogeneous network of telescopes. So instead of having like 10 telescopes, we have 160 telescopes, but each of them is different. Each of them have different pixel scale, different weather conditions, different cameras, different seeing, and so on. So we built the system which is capable of, first of all, sending the information to these telescopes and then accepting data. And also what we moved on, we helped the telescope to process their images. So people, they can respond to an alert and then they can send us the image they've collected almost immediately, and then we process internally in our system. We have built a custom-made software for this, and the software is capable of analyzing, measuring stars on these images and measuring the target of interest, for example. Then we standardize the data using Gaia data, of course, and then we provide the scientifically ready data point from that given observatory. And then if you multiply it by many targets, many observatories, and multiple observations spread over time, you actually have a living observatory, which is giving you light curves of many targets which are there in the world. So we've done this for Gaia alerts. We're doing it for ZTF alerts, for any type of alerts, supernovae, tidal disruption events, microlensing events, young stellar objects. In the forthcoming era of LSST, we're going to respond, especially to the brighter part of these, where actually, to be honest, most of the science will be done with the brighter ones. So we're there, and if you have any targets of interest, we can observe them for you. You don't need to write any proposal. Just submit your target to bhtom.space. That's the address of our webpage. Also, we expand the network with amateur astronomers because we can process their data. This is something what many people cannot do. They can observe, they can collect images. They have very good cameras, very good telescopes, by the way, these days. But we can tell them, okay, this is an interesting supernova over there. Why don't you observe it with your telescope in your garden and then give us the data? So we let people with amateur equipment, which is, as I said, very professional these days, but these people can also join doing science. So there is a lot of people willing to contribute with their observations. So we're doing this as well.
Okay, that's great. So we already, now are outside your main research interest, but still we were talking about science and the serious science that you do. But given that this interview is basically a part of the series that is called Passion and Science, that the IAU junior members organizing committee organizing, then I think that now it's really time to show that even the very serious scientists, as you are, have very fascinating passions that many people don't know. So when someone like you is at the conference, I think 99% of people don't know that there is something else that you are doing. Once when we met at the conference, I heard you playing piano. I was surprised, but this what we are going to talk about now is also very fascinating. So this connection, I think, is very beautiful because it's the connection of science and art, but it's still related to astronomy, as I think we'll all see. Because you look at the painting of Van Gogh from the astronomical point of view, right? So I think that now I will give you the floor to take us on this journey to connect art, astronomy, and your passion. So you can start sharing.
The screen. But thanks for this. But I will start before I continue that. I will show you a couple of drawings I made myself. So these are telescopes. So when you go observing, some of you might know the feeling. There's a lot of time somehow, magically. So I've been taking photographs. I was trying to take photographs of this beautiful sky you see in the observatories, but I realized that the pictures are not capable of addressing the colorful, the beautifulness of the landscape and colors in particular. So I started drawing, right? I learned the technique of dry pastels. And these are a couple of examples here. I don't know if you recognize these. So this is on the right, is Las Campanas Swope telescope. It's from 2008. I did it then. And this is William Herschel telescope from La Palma. I've drawn this in 2009. So this is what I've been doing my kind of observing time. But one of the things I also drawn is this version of Van Gogh, Starry Night. I love the painting from the very beginning. And when I was doing my drawing, I thought, okay, let's make a copy of it. Of course, I'm not Van Gogh myself. But when I use drawing myself, also for you can concentrate a lot on the object of your drawing. So like drawing the telescopes, you have to start paying attention to all these details. Where are the rails? Where is the dome? And so on. So the same here. I studied this painting. I looked at it, of course, and then I was trying to copy it. I'm not saying it's any good copy, but it allowed me to investigate some of the details of this painting, right? So we see here, of course, we see the moon, we see some buildings there. There is a cypress here, and some stars, and something there. So I started to wonder, what is this painting about, right? Why do we see all these things there? So this actually brings me to my main presentation here. So I hope you can see my slides. Yeah. Okay. I assume so. Yeah. Good.
Yes.
Okay.
Yes.
So I started digging into the history of this very particular painting, and so we know that Vincent was well, he had not a very easy life, to be honest, and so in 1889 he went to an asylum, which is kind of like a retreat place where you can, be treated like you go to a nice place where you try to recover psychologically, mostly, maybe physically as well. So this is the Google Earth view of the asylum. You see on the left, and this is where the window of his room is. So you see here, this is the window of his room. It was on the first floor, and the window was facing east, almost exactly east. There's something like 15 degrees difference. So I've studied this with Google Earth, how exactly this direction was towards east. Why is it important? Because Van Gogh was in the years 1889 and 1890. He has painted a lot of paintings which look kind of similar in a way, because they were showing what was visible from his window, right? So that's why I found it important to study where was his window facing. So, and if you look into Google Earth, you see the image here from Google Earth on the right top. There is, towards the east direction, you see some mountains. I forgot the name of it, but it's part of the Alps begin there. There's a proper name for these mountains there. They're not that very high, but still they dominate the landscape. They dominate the horizon in particular. And these mountains, they appear almost on every painting drawn by Vincent. Another thing which is always present is this wall. You see the wall here on this painting. So this is the wall of a field which was just in front of his window. So these are the things which are very common in many paintings. But that gives us a frame, right? So we look through Vincent's window, and that gives us a frame, and then the mountains in the background, and then the wall is also a frame, which is not changing over time. Then what I'm trying to argue here is that Vincent was studying the sky already from the very beginning. When he arrived in May 1889, this was one of his very first painting from that period. This was so you see the nice spring wheat in this field, but then if you look at the location of the sun, it's located in this close to this mountain there, and if we simulate, and then if we go to Stellarium, and if we take 20th of May 1889, we see that this location of the sun was reflected correctly, I mean astronomically correctly, on the image. To emphasize this is a painting from half a year later. Again, we see the wall, we see the mountains, we see the field, but then look at the location of the sun, and it's located towards south, right? Because here we have winter. So the sun, it's almost, it's mid-December, where we have the sun located towards southeast direction. So this proves that he was observing through his window, and he was noting, there is a lot of expressionism and impressionism, I must say, in these paintings, of course, but also there is a lot of realism there. Meaning that the sun is placed in the correct location where it actually was. The same applies to the moon. This is the moonrise. This is rising of the moon in July 1889. And again, we see the the stellarium simulation from 12th of July. This is the almost full moon. I think it's almost full moon around that time. So it was rising at 9 p.m. around 9 p.m. So he was observing the sky both in the morning, so observing the sunrises, but also in the evening observing the moon rises. Again, you see here the landscape is fairly similar. We see the wall, and we see the wheat being collected here already in July, and then there is behind the mountain there is this moon rising. Again, so this is to emphasize that his observations were correct, right? And he was taking the correct locations of the stellar bodies on his paintings. Okay, so what I looked into as well was the weather reports. So now getting to the Starry Night painting. So to narrow down when was that painting done, I asked my friend from France, Stéphane Bassa, and he fairly quickly found digitalized versions of meteorological weather reports from essentially the entire century. So this is from a school, École Normale de Avignon. Avignon is something like 30 kilometers away from Saint-Rémy. So we can assume the weather patterns were more or less similar. And as you see, the records were taken every 3 hours. Essentially, it's fairly accurate measurements. So there is the pressure, temperature, wind, temperatures, and other additional remarks. So based on this, we could figure out when was the most suitable time window when he could actually observe, Vincent could actually observe the sky. Essentially, if it was rainy or cloudy or stormy, then he could have not observed the sky at all. And so I looked into several dates, and it turned out that June was actually very cloudy and hot towards first half of June. As we said, he arrived into this asylum in May. So I managed to rule out a couple of dates in May as well. And then in June, there was a lot of thunderstorms and some heat waves and so on. And then the very first date where everything cleared out based on these weather reports was June the 17th. So this is the sky Vincent could have seen, clear sky, first clear night. So earlier that day, there were thunderstorms, and they all cleared out in the evening. So you can imagine, you know, how the weather looks like after a thunderstorm, right? Everything is cleaned, cleared, and the air is much better transparent. So this is the night starting on at 11 p.m. on June the 17th, as seen from Vincent's window, right? So we look towards east, we see a little bit towards south and a little bit towards north, right? So this is our frame. It's of course done with stellarium. So this is the frame we look through, and we assume Vincent was also looking through. So what we see here, right? We see, of course, in front we see Altair. Then towards the right, we see very bright Jupiter. But what is most important here, we see a Milky Way, right? It spans across the entire frame. And bear in mind that it was 1889, so there was essentially no light pollution back then, right? So he could have seen the Milky Way pretty clearly, right? If he was drawing this these days, he would have probably not seen it at all. Anyway, so that's the view at 11 p.m. Then let's move on 1 hour. 1 hour later, Jupiter moves away towards the right, so probably almost disappearing from the frame. Altair is a bit higher. Milky Way is still visible, spanning through the whole image here. We go on 1 more hour. There is a moonrise. So the moon is rising, the Milky Way is going away, And then 1 hour later, the moon is properly up. And here it's a little bit enlarged to be seen better, but at around 2 p.m., the moon is there already towards southeast direction. Then let's move to 3 a.m. And then at 4 a.m., we see the rise of Venus, and also Capella star is appearing on the northeast. And then because it's June almost summer solstice, so at 4:30 it's already getting brighter. So there is already the sun is almost is ready to get up. So this is the final view over in the morning. So my theory here, let me play this whole night again to you. If you look at it from the very beginning of the night, again, the night started quite late, right? Because it's June. And if we look through the entire night, like a movie almost, right? We see this. That's my theory here, is that the painting here is not a still frame. It's not an image like a photograph we've taken. That's what people were always thinking about this, that it's a particular moment of time overnight. My thinking here is that this is actually a collage or a composition of everything he has seen over the whole night. And actually we can see that in the letters he wrote to his brother, because we know a lot about Vincent's paintings from the letters he wrote to his brother Theo. He wrote on the 18th of June to his brother that he has painted the study of the night sky, right? So if we focus on this is a study of the night sky, right? So he was observing through his window the entire night, but he was not drawing. This is something what my friend told me, who knows about art a lot. Vincent was never doing his painting in his very room. This is because the paints themselves at these times, they were toxic. So he was not allowed to keep his actual paints in his very room. So what he did, he was actually he was making a pencil drawing, right? Studying the sky and then making a pencil drawing. And then later he went down to his studio and then painted this. So what I suggest, what we see here is, of course, we see the moon, and the moon is shown here. We can discuss it more about the phase of the moon, because this doesn't look natural, at least from the drawing. But I think if you look at the phase of the moon, which I claim it was at that very day, this is more or less expressing that this southeastern part of the moon is not lit up. Then there is Venus, of course, here rising, and then there is the Milky Way going through the entire frame, right, in the direction we could see it. Now, actually, moreover, the twirl in the center here on the painting could be this could be actually the very center of the Milky Way, because he could see the parts of Sagittarius at the time. So that's what I suggest here, that this is a study of the night sky. And of course, what we see here, we see the mountains in the background, right? So they define our frame, and as we've seen in the previous paintings, his locations of stellar bodies were accurate with respect to these mountains. But on top of that, we see the village, right, which was not there, of course, because it was pitch dark, right? He couldn't see anything. So people say that he has drawn his village, his home village from the Netherlands, where he came from, which is quite possible, just drawing from his memory. But the main figure here is the cypress, right? It wasn't there in front of his window. There is even no wall, right? Because he couldn't see the wall. So he has added, because he was an artist, and there are some certain things you have to do on an image to make the image look good, some proportions and so on. And I only know a little bit about this. So, but then the cypress was added here, and it was taken from some other paintings, and I dig them out. So you see the cypress here on two paintings of him. which were drawn. So they were drawn in plan R. I forget my French. So he was allowed to go out of his asylum, and there is a couple of paintings drawn when he was, taking his drawing kit and drawing outside. So this is a cypress which has been there somewhere close to the asylum. And we know that he has seen this cypress before the June 17th, right? Because on 16th of June, he has wrote to his sister that he has just completed the painting just a few days after he was allowed out to paint en plein art. So we know that at least the last one was painted before the 17th of June. So we know he has seen the cypress before. And you see, this is the very same cypress, right? It has the very same features. And then in July, it's another version of that cypress. Okay, so that would be it about the Van Gogh stuff. And I can stop here and take any questions if there are any.
Okay, so that's super exciting to see. So I think that now we can take the questions from the audience first. Just open the chat. And in the meantime, when people are, or Fateme?
No, like really great talk. I enjoyed it thoroughly. Yeah, I was just having this random question that like, how did you think about Van Gogh like among all the like let's say like, I mean we also have like other works of art that are like great, but then why Van Gogh? Why was it always for you, Van Gogh?
Well, I think it's a question which is obvious. The answer is obvious because Van Gogh, right? This is Van Gogh, right? This painting is so amazing and it's everywhere. And well, I've seen it live in real life as well. It's so amazing to see, and it's been, it's very artistic in one sense, but it's also very astronomical, right? So it kind of appealed. It was calling to me very much. And as I showed, I did my own copy of it as well. So I was really enjoying this picture very much. But then it also intrigued me, right?
But then
Right. I mean,
related.
Starry Night is a masterpiece, right? We have all like seen it. Yes.
Exactly.
I mean, yeah, for astronomers is a very particular figure, let's say.
Yep.
And then I have a related question. So are you thinking about fact checking also some other pictures, like paintings of astronomical objects?
I'm not that keen on looking into other pictures because I love this one so much, right? But you're right. In principle, it is possible to dig into other paintings as well, although it's quite a lot of work, right? Because we need to know.
Yeah, you now build a methodology, right? So
yeah. But so you need to know the context, right? You need to check the biography, where people were, what was the weather, and what was the sky. So many components there, right? It's fun, and I enjoyed it very much. But yeah, if you can point me to some other paintings which you suspect could be realistic in a way and not just artistic, then I would be happy to look.
Yep, that sounds great. So, do we have some other questions?
No, I think that's it. And yeah, thank you so much for your participation. And again, thanks so much for accepting our invitation. We're very honored for hosting you.
Thank you very much. That was fun. I'm happy to talk
No
about
worries.
it.
Yeah, no, it is exciting.
Yes. Okay, see you around. Take care. Bye.
Thank you.